Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 3 from the June 2016 Core Mathematics C3 paper from edXL. This is like related to the P3 syllabus of the new specification. This is like an older paper from the old C3 spec. But the concepts are basically the same. And one of the students has asked me to answer this question, so I'll do so. So it says express 2 cosine theta minus sine theta in the form r cosine theta plus alpha, where r and alpha are constants, r is greater than 0, and alpha is an acute angle between 0 and 90 degrees. Give the exact value of r, so they want r in its exact form, and give the value of alpha to 2 decimal places. Okay, so keep that in mind. So now, we want to express this in terms of this form. And that will help us in many different ways. If we want to solve equations involving something like this, or we want to sketch a graph that looks something like this, writing in this form will help us to do so. Okay, so how do we write something like this in this form? Well, what we can do is as follows. Okay, what we can do is as follows. We can say that let's call 2 cosine alpha minus sine theta. We want to write that, and we want it to be identical to r cosine of theta plus alpha. That's what we want to do. We want to write this so it looks like this. Now we can use the formula sheet and the addition formula they called to expand this cosine theta plus alpha. Right? So don't make the mistake of thinking cosine theta plus alpha is going to be cosine theta plus cosine alpha. That's a huge mistake. All right, this doesn't mean cosine times this bracket. It means cosine of all of this angle. All right, so there are some proofs which we're not really the time to go through it right now. But if you look at the formula sheet, you'll see exactly how we can, write these as separate angles. And the formula sheet will have cosine A plus minus B, like that, equals, and it will say cosine A, cosine B, and it will say minus plus sine A, sine B. That's in the formula sheet. It's one of the addition formulae, right? So we can see that when you have cosine of an angle plus another angle, this is how it's going to split up as cosine of the first angle times cosine of the second angle. If it says a plus here, there'll be a minus between them. The sine of the first angle times the sine of the second angle. Okay, there's also one for sine A plus minus B, which is different from this, but for now, that's what we need. So we look at the formula sheet, look at this if you forgot what it is, and then we're going to rewrite this in this form. So we have r times, and then this is going to split up into cosine of theta, cosine alpha, minus sine theta, sine alpha. Okay, so that's what that becomes. And then we got this r that's multiplying both of these terms. So just to make it complete, we're going to multiply r with these two. So we have r cosine theta times cosine alpha minus r sine theta sine alpha. So we have basically 2 cosine theta minus sine theta. We know that it can be expressed like this. Okay, if we can find the value of r and the value of alpha, we can fill those parts in and write this in this form. And this is what we're going to do now. Now, what we're going to do now to find the value of alpha and r is we're going to compare the coefficients on both sides of this equation. So I'm going to compare the coefficient of, let's start with cosine theta. There's a cosine theta. All right, so what is the coefficient of cosine theta on this side of the equation? Well, it's 2. And that must be equal to the coefficient of cosine theta on this, because these two are identical. This side is identical to that side. So the number of cosine thetas we have here must be the same number as cosine thetas we have over here. So 2 must be the same as r cosine alpha. 2 is the same as r cosine alpha. Okay, and I'm going to write this underneath. All right, so we have compared the cosine thetas. Now we're going to compare the sine thetas. Right? So I'm going to compare the sine thetas now. So we can see here, on this side you have minus sine theta, and here you have minus r sine alpha. So we can just call it basically a 1 here. So minus 1 sine theta, so we can call it 1 because there's a minus on both sides, so there's no problem, they'll cancel out. So 1 is equal to r times sine alpha. Okay, so here we have these two equations. Now we can solve this in two different ways. Okay, we can solve this equation to find r and alpha. One way is to rewrite these as this is sine of alpha is equal to 1 over r. And the cosine of alpha is equal to 2 over r. Okay, so we can draw a right angle triangle. Okay, and we can call this angle here alpha. And the sine of this angle is opposite over hypotenuse, so that's 1 over r. The cosine of this angle is 2 over r, so 2 is there and there, r is there. So we can use the fact that this is a right angle triangle we drew to find what r is. We can say r is equal to, by Pythagoras, the square root of 2 squared plus 1 squared, which is the square root of 4 plus 1, which is the square root of 5. In the exact form is 5. So we have the exact value of r. And we can find alpha very simply also by simply just using, the ratio of a right angle triangle. We know that the tan of the angle alpha is equal to 1 over 2. Now we want the angle in degrees. Okay, so alpha is equal to the inverse tan of 1 over 2. So alpha is going to be, take a calculator, we make sure that it's in degree mode, which it isn't, so we're going to change it to degree mode. And then we press inverse tan of 1 over 2. And that gives us 26.565. 26.5650 continues. So they want the angle to two decimal places. So 26.57. 26.57 degrees. So there is the answer for alpha. Okay, so this is one method using the triangle. This is using a triangle, making a right angle triangle from this. You can also do this another way. We can take these two equations and square both sides of these equations. So this equation, if I square the whole thing, I'm going to get 1. And I'll get r squared, and I'll get sine squared alpha. If I square this, I'm going to get 4. I'm going to get, again, r squared, and I'm going to get cosine squared alpha. So if I add these two equations together, so I'll call this equation 3 and 4. If I add these two equations together, I'm going to get 5 here. If I just add them together, equals, I have r squared sine squared alpha plus r squared cosine squared alpha. Okay, and we can see here what's common in these two terms is r squared. So I have r squared times, in brackets, sine squared alpha plus cosine squared alpha, and that's equal to 5. Okay, and then I can basically say sine squared alpha plus cosine squared alpha is equal to 1. We know that sine squared alpha plus cosine squared alpha is equal to 1. So this gives you 5 equals r squared. Therefore, r equals the square root of 5. And if we take equation 1 and 2 and we divide equation 1 divided by equation 2 back to here, okay, then we can say that we'll have r sine alpha, okay, over r cosine alpha equals 1 over 2. And we know the r's cancel, and we're left with tan of alpha equals a half, which will be the same thing that we do there. Therefore, alpha equals the same answer. All right, so this is an alternative way by squaring the equations. Okay, we can square both sides of the equation, and we will get, same answer that way. So personally, I like the triangle method better, but they're both fine. Okay, so I showed you both ways. So now, the question says express this in this form. So in the end, we should write down that 2 cosine theta minus sine theta. So we should write down 2 cosine theta minus sine theta is identical to, now we can write r as root 5 times the cosine of theta plus 26.5 So we've got alpha is an angle between 0 and 90, and r is in its exact form, and alpha is given to 2 decimal places. So there is the final answer for part A. And we will use this for sure in part B. So let me just copy it. Okay, so part B. All right, so that's the answer for part A, which we're pretty sure we're going to use now. It says hence, and the word hence means using what we just did. Okay, there's no choice. It's not like or otherwise, just hence. Solve for 0 to 360, angle theta. 2 over cosine, 2 cosine theta minus sine theta minus 1. So what we can do is we can, first of all, rewrite this, okay, in this form. Or first of all, what we could do actually, we could just multiply both sides by this whole denominator. So we'll have 2 equals 15 times 2 cosine theta minus sine theta minus 1. Okay. Now what we can do is we can replace this. Okay, by this. Right, they're the same. Okay, as we just proved in the first part of the question. So now I can say that 2, in fact, to make it even easier, I can say 2 over 15 is equal to, and then I'm going to have root 5 times cosine of theta plus 26.57, okay, and minus 1. So now I can add 1 to both sides. Okay, I can add 1 to both sides. So I end up with 2 over 15 plus 1, which is going to be 17 over 15. 17 over 15 equals root 5 times cosine of theta plus 26.57. And now I can divide both sides by root 5. So I can say cosine of theta plus 26.57 is equal to 17 over 15 times root 5. Okay, I don't need to rationalize the denominator or anything. I can now try to find my angles. So I have theta plus 26.57 will be inverse cosine of 17 over 15 times root 5. But we have to be careful now that we catch the angles that we need to. So we have to do some adjustment to the limits such that it matches what's inside here. So we have 0 is less than or equal to theta less than 360. So we have to take, this theta has now become theta plus 26.57. Okay, so this becomes 26.57, and this becomes 386.57. We have to add 26.57 to each part of the inequality. So our limits that we're going to catch the angles from is between these two values. We can't get outside of those values. All right, so we have theta plus 26.57 equals, now the first angle, the principal solution is given when you find inverse cosine, and we're in degree mode, yes, 17 over 15 times root 5. Oops, 15. That's going to give us the principal solution, which is 59.546. Answer should be to 1 decimal place, so yeah, that's good enough. For now, just write it to a higher degree of accuracy, 59.546 degrees. That's the principal solution. And that's within the range that we have set for ourselves here. Now, there's another solution for the cosine curve, which is found by doing 360. I'll do it here, 360 minus the principal solution. So it's 360 minus 59.546. Okay, so you take this, you do 360, take it away, the answer, that gives you 300.454. 300.454 degrees. Is that within our range? Yes, it is within our range. Now, any other angles that we can find will be outside of the range because they just repeat every 360 degrees. So if I add 360 to this and this, they'll both be, of course, way outside the range. So now, that's what's going to give us our solution. So our solutions for theta is going to be, we have to adjust this. We have to now subtract 26.57 from both sides. So we have 59.546 minus 26.57. And we have 300.454 minus 26.57. Okay, we could use this to a higher degree of accuracy if we wanted to, but we don't need to because we have to give our answers to one decimal place. So if this was given to one decimal place in the question, it would have been better to go back and get the answer to a higher degree of accuracy, like this is, for the answer to this question, which is one decimal place. But because we want to give the answer to one decimal place, and both of these are more accurate than one decimal place, then it's perfectly fine to just use them as they are, like this. So I'm going to have, let's start with this one, 300.454 minus 26.57. That gives us 273.883, 273.883 degrees. And here we're going to have this original answer minus 26.57, and that gives us 32.976 degrees. So the final answer to one decimal place will be 33.0 degrees, and we'll have 273.9 degrees. Okay, so there we have our answers for part B of this question, and now we're going to go on to part C. So it says, use your solutions to parts A and B to deduce the smallest possible positive value of theta, for which this 2 over 2 cosine theta plus sine theta minus 1 equals 15. Give your answer to one decimal place. Now, I'm pretty sure that many students looked at this question and they thought, hold on, this is the same question as part B, except they just want the smaller of the two angles. And I'll say, okay, it's worth 2 marks, and they wrote that down. Just wrote down the answer, or repeated the answer from part B, but just the first angle, because they didn't read the question carefully. And you've got to be very careful about this. If we go back to part B, this is in fact what the question looks like. Now, even now, many of you might look at these two and you might think, oh, they're the same thing. And this is a bit of a nasty one by the examiner, to be honest. In an exam, especially, it's like a exam situation. But look at the difference. The difference is here. That's the difference. Okay, so they're not the same question. So there's going to be a difference in the answer. How is the answer going to be different? Well, when we rewrote this, it came out like this. Okay, so the answer to part A was like this. I've just got the answers kind of copied across because we're using the answers. This is the answer to part A because it says use your solution to part A. We don't have to do the whole thing again. Now for part A, okay, which was this one here. Okay, this is what we solved in part A. This has a minus sign between like this. And this part of this ended up being root 5 cosine theta plus 26.57. Now, if it's like this, if we have 2 cosine theta plus sine theta, now that part of this is going to become root 5 times cosine of theta. Instead of plus, it's going to be a minus 26.57. Everything else will be the same. Everything else will be exactly the same, okay? Because, when you set it up, it will be exactly the R will give you the same value, the angle will be the same value. The only difference will be a minus sign between these two angles, all right? So that's what causes a difference in the answer. So if we go back to our original solutions, part B, okay, we started with this and we ended up with something that looks like this, okay? So this led us to this answer for the first angle. Okay, now the difference is going to be simply in this part over here. Instead of theta minus, so this for part C, what's going to happen, you're going to have, this, which is 2 over 2 cosine theta plus sine theta minus 1 equals 15. It will lead us, we'll go through the same steps, exactly the same steps as we did in part B. So we don't have to repeat that again. But what we should understand is going to lead us to this theta minus 26.57. Oops, what am I writing here? Minus 26.57 is equal to 59.546. So the smallest positive angle is going to be, in this case, 59.546 plus 26.57. So the answer is going to be, we take this answer, 59.546 plus 26.57. And that gives us 86.116 degrees, which rounded to one decimal place gives you 86.1. So theta is 86.1 degrees, and that's the smallest positive angle for which this is true. Okay, so that's a bit of a sneaky little one from the examiners, because many people won't even notice the difference between these two, but you got to look very carefully. So you first are going to think, hold on, it's the same question again. Why would they ask us the same question again? And that's what you should ask yourself in such a situation. Why would they ask you for exactly the same question again? And they think, hold on, let's look a bit carefully, and then you'll notice the difference. Okay, so we don't have to repeat all the work we did in part B. Okay, we can just just take that part of it and continue from there. And that concludes the question. I think that was the part of the question which the student who asked this question had issues with, but we did part A and part B. Hopefully that would benefit some students who might have some problems with such a topic. So I think that would be useful. So anyway, thank you for asking the question. And if you would like to see other questions from this paper, which I think there was another question the same student asked me to answer, I think question 9, I'll probably put that in the playlist as well. If you have any other questions from this paper that you see that you want me to answer, you can send a little message and I will do so, and as soon as I can. Okay, and you will find the questions added to the playlist over here. You can find other questions dealing with this topic, which is to do with trig identities and equations of P3 now. P3 is the new C3 syllabus. And I'm going to put these R, cosine, sine type questions. I'll have a special playlist just for that eventually. And I'm going to put that playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.